Thank you, Keith, for joining. So I'm going to do a quick overview of what Globus is and what the service provides to our subscribers. And then Keith will talk about how Google Cloud plays into that ecosystem and how we jointly deliver value to folks that are doing research all over the world. But a word about Globus. So we are a group at the University of Chicago that's been operating this service since 2010. Actually, we launched at SC10 in New Orleans, so we're celebrating our 10-year anniversary. And we have this mission to really make it more efficient for anyone working in data-intensive science and research to move data, share data, and to do so through sustainable software. So sustainability is really core to our mission. And so far, we've seen substantial growth in the service over the past decade. We're now active in over 80 countries, and we move, it's nearing now almost a petabyte of data per day. Development of the Globus service is funded by a few federal agencies as well as other organizations. But we also rely extensively on our subscribers. So we have a number of institutions that pay annual subscriptions to help us operate the service. And that's what gets us closer to sustainability. So let's talk about a few of the common use cases where Globus can add value. At its core, Globus is a reliable file transfer service. So moving data between any two endpoints, as we call them, any two storage system types, is really easy. You just fire and forget a transfer. Globus manages the whole process, recovers from errors, and so on. And even more importantly, in a collaborative research environment, we allow users to share data with others that don't usually have local account access on the systems where the data live. So they don't necessarily have to create special structures just for the purposes of sharing data. And increasingly, we're seeing growth from data coming off instruments, next-gen sequencers, cryo-EM, advanced light sources, and so on. So we have instruments now generating many tens of terabytes of data per day, and getting the data off these instruments reliably and storing it in the appropriate places is an area where we're playing an extensive and important role. And further downstream, when you have data that needs to be distributed within a broader community or shared with collaborators, we have a number of organizations that have built data portals, science gateways, data commons that allow easier access to the data. They have advanced search capabilities, and they have a number of ways to pull data down to other systems, both through Globus managed file transfer as well as through the browser. And another common use case is staging data into HPC resources, clusters, and so on, staging it in, staging it out as part of automating the data compute process. So that's enabled by the command line interface that Globus provides. And as I said earlier, we have these things called endpoints that make it all possible. So an endpoint is a storage system that has the Globus Connect software installed, as well as the Google Cloud connector. So that allows you to move to Google Cloud from many different types of storage, and they all share the same, the sort of uniform interface. And with that, I'll hand it over to Keith to tell us a little bit more about the Google Cloud solution.
Thanks, Faz. So I briefly want to review what Google Cloud is and then put it into context of why you should run your HPC workloads on Google Cloud. And then lastly, I'll talk about our research credits program. Next slide. But first, we fundamentally believe at Google that you don't need to be part of an R1 institution or have a large endowment in order to get access to supercomputers and the resources that they allow you access to. We believe using the cloud that we can democratize high performance computing and make it universally accessible and useful to anyone, whether they're part of a large R1 institution or a smaller institution. To that end, Google Cloud offers a bunch of components to facilitate those workloads. So when you look at HPC workloads, traditionally they're very variable. This notion of a square peg and round hole doesn't necessarily have to apply when you look at the cloud. So when you look at your infrastructure, something like Google Cloud can allow you to customize the resources that you use within your cluster. So no longer do you have that workload being the square peg having to match to whatever's defined in that round hole. You can have CPU, memory, storage defined specifically for your workload without having any overutilization or underutilization. We also have a large bench of partnerships. Globus is one of those partnerships on the storage front, but we also have extensive partnerships on the scheduler front as well. For instance, we have a partnership with SCED-MD, whereby their Slurm engine integrates seamlessly with Google Cloud's infrastructure. And not only do we have partnerships to provide the tools to our end users, we also have some native products and solutions to help you with your HPC needs. Whether it's our life sciences API for those bioinformatic workloads, or if you need a high performant scale out NAS solution, our file store solution provides just that. Next slide, please. So why should you move your workloads to GCP? Well, as I mentioned earlier, we offer flexible compute options. Not only do we offer custom machine types by which you can define the CPU and memory parameters for your instances, but we also offer a large array of GPUs. We offer compute optimized VMs that are specifically geared toward HPC workloads. And for those batch and high throughput workloads, we offer preemptible VMs, which enable an 80% discount off the cost of the instance. Another core component of an HPC environment is the network. And here at Google Cloud, we have one of the largest privately managed networks. Not only does that minimize the risk of customers being exposed to the public internet, but it also affords you the benefits of minimized latency when you're scaling out your workloads across hundreds and thousands of nodes. We also are a strong proponent of open source. We believe in the power of open source, gives customers the freedom to choose, what their workloads run on, and avoid vendor lock-in. And lastly, we have the latest hardware within our cloud. So whether it's the latest CPU architecture from Intel as far as Cascade Lake, or AMD as far as their EPYC Rome processors, we afford you, the end user, access to the latest and greatest hardware without having to purchase that sunken cost for your on-prem environment. And to allude upon the open source community, over the last 20 years, Google has made lots of investments in scientific computing products and solutions. So if you look at 2004 with Hadoop and MapReduce, we incubated that product internally within Google and then consequently released it to the open source community. Similarly with Dataflow and Kubernetes, both those products were incubated over the years within Google. We decided to release them to the open source community. And not only are they in the open source community, we've also turned those initiatives into fully managed offers within Google Cloud. So for instance, with MapReduce and Hadoop, Dataproc affords you a fully managed open source based Hadoop cluster. And with Kubernetes engine, we're giving you a fully managed open source based Kubernetes environment. Next slide. And then for those researchers who are in the midst of writing grant proposals, we allow individuals to apply to what's known as our Google Cloud Research Credits Program. So faculty can submit an application to receive up to $5,000 in Google Cloud credits. This will allow them to kickstart their grant proposal or their research. And not only is it open to faculty and PIs, PhD candidates within organizations can also apply for up to $1,000 in credits as well. You can find more details on this at the link below. And with that, I'll turn it over back to Vaz.
Thank you, Keith. So what does this look like from a deployment standpoint when you have Google Cloud Connector? So the way we deploy Globus Connect, the software that creates an endpoint, is on one or more data transfer nodes. So we install Globus Connect server, we add Google Cloud Connector, and by the way, we also support Google Drive for those that have smaller data that they want to move from Google Drive onto Google Cloud. And then those gateways enable access to the backend storage services provided by Google and can be accessed by users via these things we call collections. So what does this actually mean for researchers? The one thing that I mentioned earlier is you have access to this very diverse set of storage systems that you can access via a familiar interface. So it basically looks like you're browsing your local files, whether you're looking at a Google Cloud bucket or if you're looking at some high performance compute store on premises. It also provides the appropriate interface to the appropriate storage for the right types of data. So we do, as I said, have a number of institutions that have Google Drive as a means for collaborative document sharing and so on. But when they have larger data sets, which are more common in the research environment, they can put those on Google Cloud Storage, and the connectors enable migration to and from those environments seamlessly. The other thing that the Globus for Google Cloud enables is managing of the constraints and some of the requirements that are in place for accessing these services. So for instance, if you're moving data from Google Drive to Google Cloud, there are API rate limits that you have to manage. So you don't have to worry about any of that. The Globus connector will just handle it for you and make sure your data gets delivered reliably and securely. And then finally, you've invested a lot of time in your research, obviously, and with the Globus connector, you're able to share the data with your collaborators, and essentially all research nowadays is collaborative. So we make it really trivial for you to give access to your data, again, with very fine-grained access control and permissions tracking to your immediate team, to the broader community, and also perhaps to publish data out to the world. And so with that, I'll put up some links here for those that want to follow up.